In this problem, we're asked to find I0 of t for t greater than 0. We're going to utilize our problem-solving strategy entitled S-domain circuits. In step 1, we're asked to draw the circuit at t equals 0 minus and find the initial conditions. So if we draw that circuit, here's a circuit at 0 minus. We assume that we're in steady state, and we replace the inductor with a short and replace the capacitor with an open. So now we need to go through and find the initial values. So I0 0 minus is going to be 10 minus 20 over 10 minus 1 amp. Now we can find VC0 by going around this loop. So VC0 minus, we'll have 2 times minus 1 plus 20, or 18. So now there are our initial conditions for the inductor and the capacitor. Now step 2 says draw the S-domain circuit. So here's our S-domain circuit, and for instance, this element is L I0 of 0, and this one is VC0 over S. So that's how our initial conditions get entered into the circuit. So now step 3, we're going to do our analysis. We're going to use the current I0 of S. So if we start and apply KVL to this circuit, we'll have 2 I0 plus 1/3 S minus a minus 1/3 plus 20 over S minus 18 over S plus 8 over 3S times I0 of S equal to 0. And now let's start working on this. So we have 2 plus 1/3 plus 8/3 over S times I0 is minus 2 over S minus 1/3. And if we multiply through by S, we'll have 1/3 S squared plus 2S plus 8/3 times I0. And we'll have minus 2 minus S over 3. Now let's multiply through by 3. So we have S squared plus 6S plus 8 times I0 is equal to minus 6 minus S, which we can rewrite as minus S plus 6. And now we're ready to solve for I0 of S. So I0 of S then is minus S plus 6 over S squared plus 6S plus 8. So that completes step 3. Now we have a ratio of polynomials in S for I0. Step 4, we can now go in and do the inverse transform. And if we look at I0, if we notice the denominator factors into S plus 2 and S plus 4. So now all we have to do is find K1 and K2. So K1 we multiply through by S plus 2, and then let S equal minus 2, and we get minus 2 out of that. And then for K2 we have minus S plus 6 over S plus 2. We evaluate S equal minus 4. We get 1. So now we've completed the partial fraction expansion. So I0 of S is minus 2 over S plus 2 plus 1 over S plus 4. So I0 of t then is minus 2 e to the minus 2t plus e to the minus 4t u of t amps. And note that the initial condition checks, we plug in t equals 0, we get minus 1, which was the initial condition we started with.